Okay, this is for Algebra 1, and this is talking about quadratics and solving them by graphing. Remember that a quadratic function is a function that has an x squared. So an example would be y is equal to 3x squared plus 2x minus 4. We learned previously that the 3x squared is your quadratic term, the 2x is your linear term, and the negative 4 is your constant. This particular quadratic function would open up because this is positive, which means that it would have a minimum. But today we're going to move on and we're going to talk about how to solve a quadratic function. Remember that the graph of a quadratic function is called a parabola. It is either going to open up or down. It will never open sideways. That's not a quadratic function. The solutions to a quadratic function, that's what we're talking about today, solving. Remember that when we solve something, we end up with a number, like x equal 4, x equal negative 3. Okay? Solutions of a quadratic function are also called the roots or the zeros. So the problem may tell you to find the solution, it may tell you to find the root, it may tell you to find the zero. They all mean the same thing. It's where the parabola crosses the x-axis. Okay, so you have a quadratic, it crosses the x-axis here and here. So it has two roots, or two solutions, or two zeros. If you have a quadratic that does not touch it, then we say that there are no real roots in R. If you do have solutions, you write the solution as a coordinate, like this one would be 3, 0. This one would be negative 3, 0. Sometimes you'll see it written as x equal 3 and x equal negative 3. Let me back up one more step. One more thing that might happen is well, that didn't draw it very good. It may actually just touch it once. This is what we call a double root. And you have two answers, but they're both the same thing. So, kind of a summary of what we have going on with the quadratic. This is a parabola because it is the U. The vertex is the point where it changed directions. We learned yesterday. Second, calc, and either max or min is how we find this vertex on the calculator. And then this one has two solutions. Okay, they're where it crosses the x-axis. The calculator will tell us this also. You would do second, calc, and you would choose number 2 for 0. You're going to have to do this twice, once for each answer. The first time you did it, you would want to get before it crossed the x-axis and press enter once. Then you would move to the right and get after the x-axis and press enter twice, and it will give you the answer. You would have to turn around and do it again for the other one, except remember you're going from left to right. You have to be before it crosses the x-axis and press enter once, after it crosses the x-axis and press enter twice. So, to graph a quadratic function on your calculator, we talked about this yesterday. Get y by itself, go to y equal, clear it out, put it in. Zoom 6 is a great starting point so that you can see everything. So let's look at number 1. It wants us to solve it by graphing. The first thing you're going to do is put it in your calculator at y equal. So let's clear everything out, and we have x squared minus 2x minus 3. I'm just going to hit my graph button just to make sure I can see it. And if you look, you'll notice that it's something like this. Okay, I can see. This is going to be a solution, and this is going to be a solution. So what I'm going to do here is second, calc, and number 2 for 0. So second calc, number 2 for 0. I'm going to go to the left until my cursor is before the x-axis. There's not a set spot as long as it is before it. I'm going to press enter. I'm going to hit my right arrow until my cursor is after the x-axis, and I'm going to press enter twice. And it tells me that that solution is negative 1, 0, because it said x equal negative 1, y equals 0. I have to do the whole process again. Second, calc, number 2 for 0. Go to the right, so you're fairly close. You don't have to be super close. Somewhere over here, press enter. Go to the right till you cross the x-axis, press enter twice, and this solution is 3, 0. So these are your answers, negative 1, 0, and 3, 0. Number 2 works the same way. Go to y equal, clear it out. X squared plus 9x plus 5. Second, calc, number 2 for 0. I'm going to have to go a long ways to get to the far left. That's okay. You can hold the left arrow down, or you can just press it over and over. When you see that it's above or before the first place it crosses the x-axis, you press enter. Go to the right until you go past the x-axis. You're actually below it this time. Enter, enter, and it's going to be a decimal, so we're going to round it to negative 8.4, comma. Notice that y value has, on mine at least, has an e to the negative 12. Remember that that means 0. So there's one of my solutions. I do the whole process again. Second calc, 2 for 0. Go way around to the right until I'm almost to the x-intercept, or where it crosses the x-axis. Press enter. Cross the x-axis, enter, enter. And that solution is negative 0.59, comma 0. Looking at number 3, we start by going to y equal, clearing it out. X squared minus 12x plus 36. Look at my graph. I'm going to probably want to zoom in a little. It looks like it just touches it once. So if I go to zoom number 2 for n, I'm going to move my cursor over to the right until it's about at the vertex and press enter. It zooms in and I can tell that yes, indeed, there is only one solution. Second calc number 2 is going to be kind of difficult to do, but we can try it. And it does work, and you figure out that 6, 0. This is a dr, double root, because it only touched it once. There's 2 solutions, but they're both 6. Number 4, go to y equal, clear it out, x squared plus 2x plus 5. I'm going to go to zoom 6 because I know I messed with my zoom last time. It does not touch the x-axis. It looks something like this. Okay? Remember, that is NRR, no real roots. Do not tell me that this is no solution. There is a solution. Okay? It's just that it's imaginary and we don't want to go there. So you tell me no real roots. Okay, kind of changing gears. 2 numbers have a sum of 4. What are the numbers if their product is negative 12? Well, one's going to have to be positive, one's going to have to be negative. Let's call the first number x, and let's call the second number 4 minus x, because if you add them up you would get 4. Product means multiply, so x times 4 minus x is negative 12. So that would be 4x minus x squared equals negative 12. I see an x squared, that tells me it's quadratic. I want everything on the same side, and I want x squared to be positive. So I'm going to move this and this. So 0 is equal to negative 12 minus 4x plus x squared. I'm going to go to y equal and put that in. Negative 12 minus 4x plus x squared. Look at your graph. Yes, it has 2 solutions. So second calc number 2, go to the left until I'm before it crosses the x-axis, enter. Go to the right till it crosses it, enter, enter. And x equal negative 2 is one of my solutions. Do the same thing again, second calc 2 for 0. Go over towards the right and get close to where it crosses the x-axis. Press enter, go to the right till you cross the x-axis, enter, enter. X equals 6. Okay? So, if x is negative 2, what would 4 minus negative 2 be? Well, it'd be 6, wouldn't it? So your numbers are negative 2 and 6. There's your answer. When I put this up here and solved it, it was just to kind of check myself. Graph an equation with roots 0 and negative 6 if the maximum point is negative 3, 4. Remember that a root is a solution, is where it crosses the x-axis. So it crosses the x-axis at 0, that would be the origin, and at negative 6. 1, 2, 3, 4, 5, 6. It has a maximum point, so that tells me it's going to look like this, at negative 3, 4. Negative 3, 4. So you have to draw the best parabola that you can. It doesn't have to be perfect. You know the high point, you know the roots. So try to hit all of your points. There you have it. Okay, this was Solving Quadratics by Graphing. If you have any questions, don't hesitate to come see me during speed.